Good morning, ladies and gentlemen. Happy Friday. We are going to just quickly review once again how to graph a system of equations, and then you are going to have some more system of equations to practice on your own. Today we are going to start with a system of equations where we have y equal to -3. That's our first line. And I'm going to get pink so that we have y equal to x minus 3. If we want to graph our first line, y equals -3, we know that since it's y equals a number, it is horizontal. And I'm going to draw you a pretty line. A horizontal line at -3 is going to be down here. Now, if we look at our second line, it is not horizontal, it is diagonal because it is in the form of y equals x minus 3, or y equals mx plus b. My slope is the number in front of the x, so since there is no particular number, that means we have a slope of 1, or 1 over 1, and we have a y-intercept of -3. So as you can see, we are going to start right here at -3 and go up 1, right 1, up 1, right 1. Or down 1, left 1. Either way, it's pretty obvious where our lines intersect. I can fill in my second line, but our intersection is going to be right here. And that point is 0, -3. My solution is, we're not going left or right at all, and we're going down 3, so 0, -3. If I wanted to check, my y coordinate is -3, so -3 does equal -3. I'm good there. And -3 equals 0 minus 3, that gives me -3 equals -3 again. So it checks in both of our lines that we originally started with, and the solution to this system of equations is 0, -3. Oh, I'm going to have to copy once again my graph. I messed up. Not that you all would ever believe that I could mess up. I just am normally so on top of things. I know that's what you guys are thinking. Just kidding. So, we are going to have one more problem this morning. And then after we solve this problem, then I'm going to let you go to the problems that I left you. I would like you to graph the problems that I leave you on graph paper. And remember that on on Tuesday when I get back, I am going to ask to see your work. Our second equation that we are going to graph today, or system of equations, will be x plus 2y is equal to 3, and 3x minus y is equal to -5. In order to graph the first line, it has to be in slope-intercept form. So we subtract x from both sides. We get 2y equals negative x plus 3. We divide both sides by 2, or all terms by 2, and we get y equals negative x over 2 plus 3 halves. Now this one's not going to be as fun to graph because we have fractions, but it is possible, and let's see what kind of answer we get. If we have y equals negative 1x over 2 plus 3 over 2, 3 over 2 is equal to 1.5. We're not always going to have perfect numbers, so we might as well get used to that. 1.5 is going to be right here in the middle. If we go up to, negative 1 over 2 is my slope, so that means I go down 1 and right 2. I'm going to go from the middle of these two to the middle here and right 2. We're still staying in the middle. Down 1 and right 2. Down 1 and right 2. We also can go up 1 and right 2, up 1 and right 2. So when I draw my line to connect all these points, we can see that it goes down because it has a negative slope. I think the next one's going to be a little easier to graph. We are going to subtract 3x from both sides. Negative y equals negative 3x minus 5. And then we divide both sides by negative 1, or all terms by negative 1. If this were an inequality, Zach could scream out fireworks, but we don't have to flip any signs on a system of equations. Negative divided by a positive, negative divided by a negative gives me a positive 3x, and negative 5 divided by negative 1 gives me a positive 5. This way we have a y-intercept of 5, so we're actually going to start up here, and then we have a slope of 3 over 1. Well, we can go up 1, 2, 3 into the right one, or we can go down 1, 2, 3 into the left one. Down 1, 2, 3 into the left one. When we do that, look what happens. Our line actually goes through the green line just perfect. We can see that they intersect right here. If we want to give the coordinate for that intersection, we go left 1, so it's going to be negative 1, and up 2. Our solution is actually over here in quadrant 2. We can have a solution in quadrant 1, quadrant 2, quadrant 3, quadrant 4. We can also have a solution on an x or y axis. That solution can be anywhere. In this case, the solution to our system is negative 1, 2. And I'm going to be a nerd because you all know that I am a math nerd. And I'm going to check my answer using my two original equations. Right here are my two original equations. If I have x plus 2y equals 3, and I plug in my x of negative 1 and my y of 2, then I get negative 1 plus 2 times 2 equals 3, and negative 1 plus 4 does equal 3, because negative 1 plus 4, pardon me, I wrote that wrong. Negative 1 plus 4 is 3, and so it checks. Ultimate nerds check both equations, and I'm right there. So when I plug in negative 1, 2, then I have 3 times negative 1 minus 2 equals negative 5. 3 times negative 1 is negative 3. Minus 2 equals negative 5, and that is true as well. Negative 5 equals negative 5. So hopefully your brain's in the right order now. Hopefully you are all ready and set to go. You are going to graph the systems of equations that I left for you. And if you have finished all of the system of equations that I left and you are just talking away, there's an extra monomials worksheet that Miss Martinez can give to you. So Miss Martinez is prepared, I'm prepared, and hopefully you will be very busy graphing your systems of equations. Have a great weekend.